All right, in this video we're going to do linear algebra homework 2.3, and that's going to be a homework on matrix inverses. Okay, and so first we're going to just find three inverses. It's just number one is just find the inverse of the matrix, and let me do that. Okay, so if we want to find the inverse of this 3 by 3, so 0, 1, negative 4, and 0, 0, 1. We want to find the inverse. We're just going to augment with the identity matrix. And we're going to row reduce. Okay, so, and this one will be really pretty nice because of the way it's already set up somewhat triangularly. And so I'm going to take row 1 and add 2 of them to row 2. And then subtract 5 of them from row 3. Okay, so no impact, no impact. Over here, when I add 2 down that way, that'll bring in a 2. And when I subtract 5 row 1s from row 3, well, I'll just have a negative 5 here. Otherwise, this is not changing. And okay, but yeah, I subtracted 5 of this row, so again, nothing else is going to change. 5, 0, 1, 1, 0. Okay. Now I think the next order of business is going to be adding 4 of row 2 to row 3. This one was great. Why can't they all be like this? Okay, adding 4 row 2s to row 3. Okay, so this is my last step. 1, 2. Okay, when I add 8 to negative 5, I'm going to get 3. Okay, adding 4 row 2s to row 3. There we are. Okay, so this is going to be the inverse matrix. Okay, so B inverse is going to be 1, 2, 3, 0, 1, 4, 0, 0, 1. All right. Let's move that up a little bit. Okay, for a matrix that's 2 by 2, we're just going to use the trick, right? Negative 4 and 7. Okay, B is that. The determinant of B is going to be 21 minus 20, which is 1. Okay, so I know that B inverse, I can just find that by dividing by the determinant and then swapping these two and making these negative. Okay, but dividing by 1, not going to really do much, so that's 7, 5, 4, and 3. Okay, that's how we would find the inverse of a 2 by 2. All right, let's see. The next one's a 4 by 4, so I'm going to, allow myself some room to work. In fact, I'm going to anticipate there being a lot of work necessary on this one, and so I'm going to just kind of zoom out to prepare. 1, 1, 2, 0. Negative 2, negative 1, negative 2, and 2. 2, 5, 11, 8. 1, 0, 2, 1. Okay, augment with the identity. And then we will row reduce. All right, so I'm going to just clear out the first column first. Okay, I know I'm going to subtract a row 1 from row 2. So negative 1. I'm going to subtract 2 row 1s from row 3. So, but since all of these above are zeros, and nothing's going to change up there, over here. Okay, I haven't really done any work on row 1 yet, but when I subtract row 2 minus row 1, okay, negative 1 minus negative 2, 5 minus 2 minus 1. Okay. Now subtract 2 up here, negative 2 plus 4, that's positive 2. 11 minus 4 is 7. 2 minus 2 is going to be 0. And then I didn't do anything to row 4, so I'm going to just leave that the way it is. All right. Now I'm going to use this as my tool to clear out the rest of the second column. Right. So I'm going to add 2 up here, add 2 of row 2 to row 1. So 6 plus 2 is going to be 8. 1 minus 2 is going to be negative 1. So subtracting 2 row 2's. So that would be a 3, negative 2, and then 0, 0. I'm not doing anything with row 2 in this step, not even doing anything to row 2 in this step. I'm doing a lot with it, but it's not going to change. Okay, row 3, I needed to subtract 2 row 2's. So 2 minus 2 is 0. 7 minus 6, that's going to be 1. That's convenient. 0 minus negative 2. Okay, that's going to also go 0 because I'm subtracting 2 of this, subtracting 2 of that, and then subtracting 2 of these. Well, that will just not change. Okay. And then, okay, down here in the last row, I subtracted 2 of these. 8 minus 6 is going to be 2. 1 plus 2 is going to be 3. Make sure 2 minus 2, 8 minus 6, 1 plus 2. Okay. So I'm subtracting 2 up here, subtracting 2 row 2's, subtracting 2 row 2's, subtracting 2 row 2's. All right, 2 more steps, right? I just need to clear out 3rd column and clear out 4th column. Yeah. All right, so in doing that, I'm going to use this as my tool, and I'm going to subtract 3, subtract 8, subtract 2. So this is going to become 0, 0, 1, 0. And I just got to figure out, what did I do here? And then this will still be a 2. Okay, when I subtract 2 of these, I'm going to subtract 2 of those, and I'll have a negative 1. Maybe I'm going to start from the bottom here. Why not? Okay, so I'm subtracting 2 of the row above. Subtracting 2 of the row above, negative 2 plus 4. Subtracting 2 of the row above, subtracting 2 of the row above. Okay. Now I am subtracting 3 of the row below. So 3 minus 3, negative 1 minus 6. And, okay, subtracting 3 of the row below. Okay, we're not changing this right now. Okay, so in row 2, subtracting 3 of row 3, 1 plus 6. 0 minus 3, 0 minus 0. And then up here, I need to subtract 8 row 3's. So 8 minus 8, negative 1 minus 16, subtracting 8 of row 3. Okay. That's going to be a lot. Okay, so just got to be careful here. So subtracting 8, subtracting 8, subtracting 8, negative 2 plus 16, subtracting 8, subtracting 8. Okay, wasn't so bad. Okay, and then I think what I'm going to do now is I'm going to multiply this whole row by negative 1. Because I know that eventually I need that to be a 1. And now I'm going to basically, subtract 2 from here. This will be my last step. Okay, so it's going to end up being 0, 0, 0, 1. Right, I just have to track how I got there. So 2 minus 2, 0 plus 4, negative 2 plus 4. So I'm subtracting 2 of these. 1 minus 4 is negative 3. And I'm subtracting 2 of these. That'll be a 2. Okay, now for up here for row 2, I need to add 7 row 4's. So negative 7 plus 7, negative 1 plus negative 14, 7 minus 14, because I'm adding 7 of this, so 7 minus 14, negative 3 plus 14, adding 7, negative 3 plus 14, and then adding 7 of this up here. That would give me 0 minus 7. Okay. And then up here, I'm going to add 17 of row 4 to kill that off. So I need to add negative 34. Add negative 34. Add positive 34. And 34 minus 8, I think, is going to be 26. And then we're going to add 17. And so there we go. That was a lot. Okay? And then that's my inverse matrix. I'm not going to copy that. Okay? You know what we did here. We augmented with the identity matrix, we row reduced, and that took a while, but not so long. Okay? But I think that you can see how a computer would be really good at that. More accurate than us and faster than us. And so that would be nice, right? That's why we're going to use technology quite a bit in this course. All right, now we're going to use the given inverse matrices to find Q. Okay, that's great. So I'm going to actually copy in the inverses. A inverse, and I don't want you to go and use the trick to compute A, B, and C. That would not be fun, right? That would not be the thing to do. Okay, so 3, 0, 1, and 2. We're going to just use our matrix inverse properties. B inverse is going to be, what is B inverse? C inverse, oh, whoops, no I didn't. 1, 2, 2, 1. And then C inverse, I'm going to have to zoom out again, but that's fine. Hopefully this is not blurry. It doesn't look blurry on my screen. So C inverse is negative 1, 1, 1, 2. Okay, and if we want Q equals 2A. Okay. Okay, so I just need to think. I haven't thought about this type of problem in a while. I know we're just going to use the fact that 2A, the inverse of 2A is 1/2 of A inverse. So I guess we're going to say, all right, that means that Q inverse to me is, using our property, half of A inverse, which is going to be, 1.5, 0.5, 0, and 1. Okay, so I guess if we need to find Q, we're going to have to compute the inverse of this, which is, okay, it's fine. So the determinant's going to be 1.5 minus 1/2 is 1. That's convenient. And so Q is going to, okay, the determinant's 1, so I don't need to divide anything. I'm going to swap these and make these negative. That'll just be Q. All right, so number 2B is Q is B transpose. Okay. Meaning that Q inverse is B transpose inverse, which we can use one of our properties and say, hey, that's B inverse transpose. And so, all right, Q inverse is going to be, okay, the rows become the columns. Poor choice. Columns become the rows. Okay, so it is equal to its transpose. Okay. If I want to find Q, I'm going to take the inverse of this. And so its determinant will be 1 minus 4 is negative 3. Okay, we're going to swap these, make these negative. And, okay, I can do that. Okay, that's Q. Right, 2C, Q equals AC. Maybe this problem set was supposed to be find Q inverse. That would make more sense, but I'll just do it as it's written, you know. And 2C is going to be, okay, Q equals AC. Okay, means Q inverse is, remember, we have to reverse the order of our multiplication. C inverse, A inverse. So we can do that. got these. That's negative 1, 1, 1, 2, multiplied on 3, 0, 1, 2. And you can say, all right, that's negative 3 plus 0. Let's move to the right, negative 1 plus 2. Now move down, 3 plus 0, and 1 plus 4. Okay, that's Q inverse. So if we want to find Q, we're going to take the inverse of that. Is going to be, all right, take the determinant, negative 15 minus 3 is negative 18. I'm going to swap these and make these negative. And, you know, you could distribute it in the negative 1/18th, or you could leave it out like that. I don't really care. D is going to be Q is C transpose A transpose. Okay, so now we're going to get a little more intensive. 2D. C transpose A transpose, okay, meaning that Q inverse is going to be, all right, well, we'd have to reverse the order. Okay, so A transpose inverse multiplied by C transpose inverse. And then we've got another property for that, and that's A inverse transpose multiplied by C inverse transpose. Okay, so I need to actually write those out. So A inverse transpose is going to be 3, 1 as a column and 0, 2 as another column. C inverse transpose, take the rows, make them columns. Negative 1, 1, 1, 2. Okay, now I'm going to do the matrix multiplication. It's going to be negative 3 plus 0. Move to the right, 3 plus 0. And then move down, negative 1 plus 2. And move to the right, 1 plus 4. Okay, that's Q inverse. If I want to find Q, I'm going to find the determinant. Negative 15 minus 3 is negative 18. This is eerily similar to the one I just did. But, oh, I guess it would. I'm not going to think too much about this, right? So 1 over the determinant, reverse these, make these negative. That's not what I just got, was it? 5? No, okay, it's somehow slightly different from what we just did, but I mean, it's got A and C, you know, contributing, so I guess it's not surprising. All right, last one, E. Q is B inverse A. Right, and B inverse A, all right, so if I was to take the inverse, okay, that would be A inverse multiplied by B. I don't think you can't do this without figuring out what either A or B are. You know, it doesn't, and if I'm going to have to do that, I'm not going to find an inverse and then uninverse Q. So I'm just going to figure out what A is. Okay, this did not work. I'm not really sure what. I know where I got this problem set from in the book. I feel like I might have not copied something right. Anyway, I just caught this, that it's B, not B inverse. Ugh, I'm just not doing great today. It's all right, though. So now, okay, yeah. Q inverse is equal to A inverse multiplied by B. I don't know how many of those. I guess just 2B is going to be affected by me not realizing that was just regular B. I don't really understand this problem. Now it makes more sense. Okay, A inverse B is Q inverse, so it's and because B was its own B was its own transpose, I actually think that the answer for 2B might not be impacted. But if it is, let me know next time you see me. Okay, so this is A inverse B. Okay, so this is writing a formula for Q inverse. 3 plus 2 is 5. Move to the right. 6 and 1 is 7. Move down. 0 plus 4. Over to the right. 0 plus 2. That's Q inverse. If I want to find Q, I'm going to take the inverse of this matrix, and I'm going to say, all right, determinant is 10 minus 28 is negative 18. Okay, I'm going to swap these. I'm going to make these negative And that will be good enough for us, right? That's going to be Q. And that's all for number 2. Okay, for number 3, compute A inverse and... All right, so we're going to start with that. A is 1, 2, 1, 3. Okay, determinant of this is 3 minus 2, which is 1. So that means A inverse is 1 over 1 times swap these, make these negative, and, okay, that's A inverse. We want to solve AB equals D and CA equals E. And they've given us D and E, and so you just want to find matrices B and C. Right, so if I want to find B, I need to get rid of this A. So in order to get rid of this A, I need to hit it with A inverse. And because matrix multiplication doesn't commute, I need to be careful about what side I hit it on. So I'm going to multiply A inverse on the left so that I can then apply the associative property and say, oh, okay, B is going to be A inverse times D. And then just to show you, I'm going to do the exact same thing over here. And I'm going to say, all right, C times A equals E. I want to get rid of the A to solve for C. I'm going to need to multiply by A inverse on the right. So that'll be CA multiplied by A inverse is going to be equal to E multiplied by A inverse on the right. Okay. Then, eventually I will apply the associative property. I will say, oh, hey, that's the identity matrix. This is just B. This is just C. Okay. So I'm going to say, okay, A inverse we decided was 3, negative 2, negative 1, and 1. D is, where is it? It's kind of wide. Negative 1, 1, 2, 0, 3, 2. Which is going to be negative 3 minus 1. Go down 2 plus 1 to the right. All right. 6 plus 0. I guess we'll go to the right again. 9 minus 2. Go down. So I need second row, second column. Negative 4 plus 0. Negative 6 plus 2. Negative 6 plus 2 is negative 4. Okay, that's B. If I want to find C, I'm going to take E and multiply it by A inverse on the right. E is kind of a tall matrix. It's 2, 1, 0, and negative 1, 1, 3. And then I'm going to multiply it by, A inverse on the right, and I've already got A inverse right there. And then I will multiply this, and this will be 6 plus 2 is 8. To the right would be negative 2 minus 1. Move down. 3 minus 2. Negative 1 plus 1. 0 minus 6. And 0 plus 3. Okay, that's going to be C. Okay. And that was a good problem. The type of problem I would definitely use again in the future. Okay, use A inverse and B inverse, which are given below, to find M. This is more like it. This is more like what I would expect. Okay. So this is for A. M is AB inverse. And also, because I'll be honest, I'm running pretty low on time, I'm going to pull out a graphing calculator and use that to speed up the process a little bit. All right, now because I'm going to use these same matrices multiple times, I'm going to store them in, and this is actually what it would look like if you were using a TI-83 as well. I think you have to store it in. We're able to use, I think it's alpha F3, yeah, to just kind of, hey, give me a matrix right now. And that's going to be helpful for us, as we move forward in the course. But today, I actually want to store the matrix so I can call on it more than once. And so this is where the menu where I'm going to call on A. But I'm going to edit A. Actually, I'm going to go down to like H and I think. So I'm going to let H be A inverse. which is going to be a 3 by 3. 1, it goes column 5, 3, 1, 6, 2, 8, 1. Okay, and then, yeah, we're happy. I think, do I have to press enter or anything? I'm just going to quit and hope for the best. Matrix, oh yeah, I've already got H stored. I is going to be, nope, I just called on I. If I want to edit I have to go over to edit, scroll down to I, or okay. More reliably press 9, and then get another 3 by 3. Let's see, 3, negative 3, 4, 5, 1, 3, 7, 6, negative 1. Okay, that's going to be I. And so I'm just going to note A inverse is H and B inverse, that is I on the calculator. Okay, so I'm going to use the property and say, oh, AB inverse, I know that's B inverse A inverse. Okay, that's one of the things I'm supposed to know. So it's going to be I multiplied by H. So I can go in here to matrix I times, I don't think you need like a times button. No, you don't. There we go. That's, yeah, I'm glad I didn't have to do that by hand. 2, 14, 23, 35, 35, 12, 1, 34, 70. And, okay, I would hopefully give you something a little friendlier to work with. For B, I've got M equals 3A inverse. Okay, well, using the property, that's going to be 1/3 of A inverse. And I don't need the calculator to do that. I'm just going to look at A inverse and divide everything by 3. 1/3, 1, 2/3. 2/3, 1/3, 8/3. And then 4/3, 1, negative 1/3. Okay. And that's going to be M inverse. Or, no, that's M. Pardon me, that's just M. For C, A transpose inverse, which is going to be A inverse transpose. This is another one I don't need the calculator for. Maybe I should have thought about this first. Rows become the columns. So the rows of A inverse are going to become the columns of M. And so 1, 2, 5 is a row. 3, 1, 6 is going to be, or is a column. So was a row, is now a column. And then 2, 8, 1. All right, for D. M is A transpose B inverse. Okay, so that's going to be B inverse A transpose inverse. Okay. And that's the same as B inverse times A inverse transpose. So on the calculator, you can still see that. That's going to be I multiplied by H transpose. All right, so I'm going to call for I. And then I don't know what the order of operations is, so I'm going to just put a parenthesis around this, but I don't think that would be necessary. Call for H and transpose it. I got to think it's up here in math. Yep, there it is. And invalid dimension. I might not like that. I'm just hoping for the best. Let me know if this did not work. But I got to think that it's going to transpose H before multiplication with I. I haven't even really thought about it. Is IH transpose the same as I multiplied by H transpose? I somehow doubt it. But if it gave me a dimension error, that's not good. I don't know why that would happen. So 17, 22, 14, 30, 34, 21, negative 14, 21, and 61. It's experimented with the matrix capabilities of these calculators more than I have. Maybe let me know. Okay. But then the last one, I think is one that comes. It's like a trick question, and it comes back in, being pretty nice. Let me think about this. Yeah, I think this might just like be the identity matrix or something. But okay, it's got a square bracket, then a parenthesis, A inverse, B inverse, inverse. Multiplied by A inverse B. inverse. So first thing, I'm going to kind of start from the inside. These parentheses, I'm going to swap the order and make them inverse, right? So the inverse of this is going to be regular B times regular A. Yeah, here it is. Did I copy this wrong? No. Okay, that's all right. Okay, A inverse A, I'm going to take that. Hey, wait, that's the identity matrix. Okay, so B, identity B, that's just B squared, or 2 copies of B. So, right, and that's just going to be B inverse, B inverse. B inverse we designated as I on the calculator, so I'm just going to kind of square I. Matrix 9 and matrix 9. Okay, there we go. That's all. That's all. We can do that. So 22, 41, 44, 12, 4, negative 21, negative 1, 20, and 47. Okay, that's going to be all for this video. Thanks for watching.